G'day again. In this video we're going to be looking at now something a bit different, and we call it determining equations. And basically, in the last, when we were sketching, what we had is y equals 2x plus 6 or something like that, and we went and we sketched a graph, and it looked something like that. And what we're now doing, so when we're sketching, we were given the equation and we drew a graph. What determining is we're given a graph or some points or something like that, and we're going in this direction. In other words, we're given a graph and we need to figure out what is the equation. So we're going in the other direction now, and this is uses a bit more detective work, and it's uses a bit more brain power. But if you sort of follow the guidelines and rules, you'll find it pretty good. This is where this does get a bit tricky, but if you follow the rules and follow the procedures and get used to it and practice, then you'll find that it's pretty good. And what I'll do today is just give you as many sort of different situations as I can, so that you know what to do in the different situations when the graphs look like different things. Okay, so good. What I'm going to just start with is to remind you about what this equation means. Y equals mx plus c. Let's have a look at this. Firstly, what does don't complain, m here. What does m mean, and what does c mean? Okay, remember m is our gradient, c is our y-intercept. Okay, so what this means is that any straight line graph can be written as y equals mx plus c. So if you can find out the gradient of a graph and the y-intercept of a graph, then you can write down what the equation is. So there's two things we need to know. Two things we need. If you have those two things, then you're sweet, you're good. All you got to do is find the gradient and find the y-intercept of a line, and then you put it into this equation. Okay, and you've got your equation of your whole line, which will be the entire thing. Okay, so I'll do heaps of examples of this, but that is the premise of what we're talking about today. We're going to look at a graph. Can you find its gradient? Can you find its y-intercept? If so, put those two into the equation. Okay, let's just go straight into an example, because this is the best way. So firstly, we're going to look at, if you know, I'm just going to write these like this. If you know gradient and y-intercept. Okay, that's what this section is called. If you know the gradient and the y-intercept. Cool. So an example might be like this. Example, find the equation of a graph, a linear graph, don't make it just a linear graph with gradient, sorry, a bit of writing here, with gradient of 3 and y-intercept of -2. Okay, so find the equation. So firstly, just remind yourself, what are the two pieces of information that you need to be able to find the equation of a linear graph? So you've got y equals mx plus c, and if you can find m and you can find c, then you're sweet. Okay, so what do we know here? We've been given the gradient. Wow, so there we go. That's m. The gradient is 3. You've been told that. Sweet, that's nice. Also, you've been told the y-intercept. Awesome as well. That's c. You know m, you know c, so therefore you can write the equation. So y equals mx plus c, therefore y equals, what was the gradient m? 3, x plus c is -2, plus -2. Let's just rewrite that out a bit better. Y equals 3x minus 2. And that is the equation. That is what you're trying to find. That is the relationship between y and x. Okay, so that's a really easy example where you're looking for the gradient, you're looking for the y-intercept. If you know those two, then you just put those in. Instead of writing m, you write the 3. Instead of writing c, you write the -2. So that's a nice way to start. It is not always that easy though, but that is the first sort of type of question. Second one, if you know the gradient, let's say if you know, we'll say if you know the y-intercept, but not the gradient. This is our second category. You know the y-intercept, but not the gradient. Okay. So let's have a look at an example. Example here. So you've got something like this, and you're told like that, and you know the y-intercept, and you've been told that's say 4. That's 4, the y-intercept up there, and let's say you also know this point down here. Let's just say that's 8 down here. So what's the equation of this line? That's what we're trying to find out here. You know the y-intercept, you're not told what the gradient is. Well, can you find the gradient of this? That's the first question you should ask yourself. We've got C. Let's just write that down, because that means we're halfway there. Remember, we need to find M, we need to find C. Can you find these two things? That's what we're trying to find. If you find those two, you've got the equation of the line. Right, what is C? C is the y-intercept, so we've got C is equal to 4. Sweet, that's a great start. All we need to do now is figure out what M is. Now, if you look at this, we know this point on the line and that point on the line. Can we figure out the gradient by looking at its rise and its run? So if M is equal to rise over the run, let's have a look at this. Let's start at 4 and go to 8. Okay. Firstly, what is its rise? Its rise, it's going down, and it goes down from 4 down to 0. So its rise is -4. It goes down by 4. And then it goes across to the right by 8. And so it's positive 8 there. So M is equal to rise over run equals -4 over 8. And if we simplify that, M equals -4 over 8 is -half. Or -0.5, however you want to write that. Okay, so that's the gradient. That's good. So we know C and we know M. Now we can write down the equation of the line. So if you remember, and please remember this, you'll be doing it all the time, y equals mx plus c. Therefore, our equation here, y equals, put in your value of m. M is equal to -half. So I'll just write that as -half. Could write it as -0.5, that's fine. -half x plus, what was our value of c? 4. And that is the equation of the line. That is the relationship between x and y here. And that's how you do that when you're given that. Okay, so in this case we were given C, no problems, but we had to figure out what the gradient was. So a little bit of detective work in figuring out what M was. In the next video I'll show you another situation where, in a different situation, but it's still determining what is the equation of the line. See you in the next video.